Hello, this is Sayan of Fractions Hub. We are discussing IOQM 2022 solutions. We are going to discuss now the problem 11. Mm, Let's jump into the problem. The question says, in how many ways can four married couples sit in a merry-go-round with identical seats such that men and women occupy alternate seats and no husband sit next to his wife? Now, first thing we are going to do is name those husbands and wife. First couple is say H1 W1. Second couple is H2 W2, H3 W3, and H4 W4. And we are going to name the seats in the merry-go-round as give them some names. Say A, B, C, D up to H. There will be 8 seats. On that, A, B, C, D, E, F, G, and H. Now, the wives and husbands sit in alternate seats. So, let's say the husband sits in seats A, C, E, and G. Wives get the seats B, D, F, and H. Now, we are going to place the husbands first. And we are going to see in how many orderings we can do that. Now see, as this is a merry-go-round in a round, like a round table, where the first one goes doesn't make any difference. So we can put H1 in any random place, and that doesn't affect anything. So let's put H1 at position A. Now for the seat left to of H1 for husband, that is C, we have three choices: H2, H3, and H4. So three choices. Now without loss of generality, let's say we put H2 here. Similarly, for the left of H2, position E, we have two choices. And without loss of generality, again H3 is placed. So for the last one, there are obviously one choice rather, and that is nothing but H4. So we have total of 3 factorial ways to arrange the husbands only. That is 6. Now it's come the time to place the wives. Now we know the husband doesn't sit next to their wife. So H1 will not be seated next to his wife. And so the options left for W1 to be placed are F and D. So W1 can be in F or D. So there are two choices without loss of generality. Let's say it is wife one, that is W1, is seated in D. Now see that H4, the H4 won't sit next to W4. So W4 had only two choices, B and D. Now that D is occupied, W4 can only, pardon, only be in seat B. So let's place her there, W4. And that is effectively one choice. So that is not a problem. Now, for again, H3 wouldn't be seated next to W3. So W3 can't be on F. So we are left only with H. So we place W3 in H. W3 will can only be in H. And again, one choice rather. And now only one plus is left and 1% W2 is left. So let's place her there. W2 will be on F. Again, one choices. So total number of choices involved will be what? For only the wives, it will be 2 times 1 times 1 times 1. That is nothing but 2. So we'll see that wives can be placed in 2 ways once the husbands are placed, and husbands are in, can be placed in 6 ways. So total number of ways, total number of ways we can seat 4 couples with given constraints is 2, sorry, 6 times 2, that is 12. And that is the answer. So now we have done question number 11. Thank you.